Hey everybody, John here. In this lecture, we're going to talk about solving exponential and logarithmic equations. We're going to use logarithms to help us solve exponential equations, and we're going to use exponential ideas to help us solve logarithmic equations, along with some of the properties of logarithms. What is really important to remember through all of this is what we talked about in the last lecture on logarithms, is the definition of a logarithm. So just remember that y equals log base a of x is the same thing. It's not any different. It's exactly the same thing as saying a to the y equals x. So when we write something that looks like this, we can think of it as something that looks like this. What do I raise a to get this number? What do I raise a to get this number? Oh, it's the same exact thing. All right, so keeping that in mind, we're going to go back a little bit and just review some solving equations by finding the same base where we don't need logarithms. So we did this back when we talked about exponential functions, but we're going to revisit it now. So looking at the left side of this equation, I have a 25 as a base. On the right side of this equation, I have a 125. Now 125 is not 25 raised to some power, but both of these equations, both of these sides of the equation can be written as 5 raised to some power. 25 can be written as 5 squared, but that whole thing, so this is the 25 now, right? So it's still being raised to the x power. And 125 is actually 5 cubed. Now, using the properties of exponents, when we raise a power to a power, we multiply the exponents. And now, using the property of equality, if I have 5 raised to 2x and I have 5 raised to the third, and they're equal, meaning they're not even different things, that means that 2x equals 3, which means that x equals 3 halves. Now, you may have been able to look at the original equation and say, well, the square root of 25 is 5, and 5 cubed is 125, and so there's our answer. And that's great. But in case you didn't see that, this is sort of the more structured way that we can do this that will work for even more complicated ones that can't be done in your head. So same idea for this second one here. We have 9 to the x and we have 3 to the x plus 1. 9 can be written as 3 squared. So now I have 3 to the 2x. Using that power to a power, we multiply the exponent rule. And again, I have 3 to something, and on the other side I have 3 to something, and these are supposed to be exactly the same thing, so that means that 2x has to equal x plus 1, which means that x equals 1. And again, you might have been able to guess that 9 to the 1 power and 3 squared are the same thing. But we can do this for a number of problems, and you've already seen a couple of them. However, when we get to something like this, where we have 5 to the 2x minus 3 and 3 to the x plus 1, 5 and 3 don't have any factors in common. Both of these are actually prime numbers. So I can't write 5 as a power of 3, at least not an even power of 3. And so this is where I need logarithms. And so in the next video, I'm going to go through this, and I'm skipping to the next video just because this problem is going to take a little bit of time to explain, and I want to make sure that I explain it fully, and I want you to follow along as I do it, and I also want to sort of give you an analogy of how we would work with some of these things. All right? So I will see you in the next video.